Good morning again. Yesterday we went through the first part of lesson 11.1. We're going to do 11.1 part 2. And the good news is it's a pretty quick lesson because we already went through a lot of the details. So just as a review, we have a radical function, or really in this case a square root function, right? A square root of x minus h plus k. And we started with the parent function, y equals square root of x. And then we talked about what happens to each piece, right? A, if it is greater than 1, means a vertical stretch. A, if it is less than 1 or greater than 0, and actually its absolute value, means a vertical shrink. And then if A is less than 0, in other words, if it's negative, you get a reflection. And if you remember the basic function, right, just to look at the basic shape of the function, looked like this. And everything else is a change from that. We also looked at what happened with K. And K, we found K moves the function up and down. In other words, what we call vertical translation. And last, we looked at H. And H moves the function side to side, what we call a horizontal translation. So these are the main terms when we're comparing it to the parent function. What does it look like when we are graphing an actual function? Well, because I don't have a ton of room on this one, I am going to go to the next slide. And I'm going to use as my example 5 in your book. And that example graphs the function y equals 2 square root of x plus 4 minus 1. In other words, a is 2, k is -1, and h is 4. So let's think through this, right? If we are comparing, our base is going to be really y equals 2 square root of x, which you know, compared to the parent function, is going to stretch that parent function. And if we draw the graph, we're going to look at it and know, well, first of all, if the basic y equals 2 square root of x, where we know the basic function would be like this, 2 square root of x is going to be a stretch. Did not mean to draw that. What happens? Well, we know here, this is going to make it go up and down. So we're going to probably down here. And it's going to drop, vertical translation down by 1 unit. Here, because you have a value of 4, you know this is probably going to go left by 4, because if this was -4, as you saw yesterday, it would go to the right by 4. So if this is a positive, it's going to go to the left. So I'm going to make sure that as I'm drawing this, I'm going to go all the way out to -4. And I'm going to guess that this is going to be down 1 over 4. So probably my square root function, instead of starting here as y equals a square root of x, or y equals 2 square root of x would start, it's going to start here. And so now I've sort of begun to set it up so that I can actually do take some of my numbers and see what happens. Here's my table. So I can see right here that if I put in a 0, I'm going to get 0 plus 4. The square root of 4 is 2. 2 times 2 is 4, minus 1 is 3. And so I need to make sure, positive 3, sorry. I'm going to go 1, 2, 3. And my function is going to be at 0, 3. Okay, that's my first number. Now I'm going to try numbers that make it a little easier. So if I have 5, I can create square root of 9, which is easy. So 5 plus 4 is 9. Square root of 9 is 3. 3 times 2 is 6. Minus 1 is 5. So I'm going to go 1, 2, 3, 4, 5. I have 5 and 5. Okay. However, I haven't gone any further than 3 here and 0 here. And I can do some, I can go below 0, because if I put in -1, I'll get a positive 3, and that's a legal square root. If I put in a -2, I'll get a positive 2. If I put in a -3, which is a really good one to put in, I will get -3 plus 4 is 1. Square root of 1 is 1. Times 2 is 2. Minus 1 is 1. And so I realize, oh, okay, I can put in -3 for x gives me positive 1 for y. And that's good because it's looking like it might just be going the way I was predicting. The last number I'm going to put in, or next to last, we shall see, is -4. And that is tremendously useful because I get 0 inside the radicand. 2 times 0 is 0, minus 1. So as I predicted, that was my point, -4, -1. And if I want to, I might try putting in -2 just to see what happens. -2 plus 4 is positive 2. Square root of 2 is 1.4. 2 times 1.4 is 2.8. Minus 1 is 1.8. And that just sort of confirms the direction. -2, 1.8, just about there. And there's my graph for y equals 2 square root of x plus 4 minus 1. We need to define the domain and the range, as we were yesterday. And the domain, all the x values, you can see the x's cannot go any less than -4, or you'll get a negative square root. So x has to be greater than or equal to -4. And the range, you can see the domain defines the range, and so the range, you can see the y's do not go below -1, so y is greater than or equal to -1. And so now you've graphed your function, you've defined your domain and your range. The last problem we're going to look at is example 6, and this is a real world problem. So example 6, they're going to call microphone sales. And as they've done before, they're going to give you an equation for the period for 1988 to 2002, where x equals years since 1988, and y is going to be in millions of dollars. And your equation is going to be y equals 93 square root of x plus 2.2. So let's take that, and the first instruction is graph the function on a graphing calculator. So we're going to do that. Here's my graphing calculator, and I've already done it, but I'm going to take you through the steps again, as if I hadn't done it. And I'm going to enter 93 square root of x plus 2.2. Okay, I've entered that in, and I am going to show you my window. By the way, this is the window I defined if you want to get that graph, and that is because I looked at the fact that it's multiplied by 93. So you're going to have a lot of y values for the inputted x values. I put my x from 0 to 20 because there's not going to be any negative values on the x side. I put my y from 0 to 600 because everything's multiplied by 93, so it's going to go up very fast. So having shown you my window, I'm going to graph. And there's my graph of that function. You can see it's a beautiful square root function. So their next question is, what year were the microphone sales 325 million? So in other words, what is the x value when this is 325 million? In what year x, right? Well, I can use my trace function, and I'm going to use my trace function to show when x equals 10. I don't know why it did this, actually, because the first time I did it, it went right to x equals 10. But there it is, and it shows me that x equals 10 at 325 million. And so that means that at y equals 325 right here, when x equals 10, since this is the number of years since 1988, then I have 1988 plus 10 equals 1998. And I'm able to answer the question. So that is it. It's a fairly short section, and the homework should not take you too long. And I will see you tomorrow for 11.2.